either touch the pad. Everybody in the world fused. Yeah. Now then, crew, and welcome back to the Andy Mechanic YouTube channel. And the saga of the workshop roof steelwork continues. Now, I don't want to sound like I'm repeating myself, but there's been lots and lots of great ideas come through from you on the comments. And it's really made me redesign or rethink the design that I've got for this steelwork. And just to recap, if you've not seen the other videos, there's a retaining wall down the middle of the two single garages which has to come out. This workshop at the moment doesn't lend itself very well at all to do filming on vehicles, even motorcycles. You can't quite get the camera angles. So there'll be 4 lots of I-beams going across from one side of the garage to the other, and once they're in place I can get rid of this middle wall. So just to keep you up to date with the current design and how it's changed, let's take a quick look at the drawings. Here we go. Now, some of you may well recognise this drawing, and this came from our Plan B attempt, and you'll see that on a previous video. So we've got approximately from one side of the workshop to the other about a 5.5 metre span, and I've stuck with the UB14 I-section beams to bridge that gap because I need to maximise or maintain the maximum roof height available. Because you know, we put motorcycles on the hoists and stuff, and you don't want the mirrors, you know, banging onto the lights and stuff. And obviously this side of the workshop with the apex roof is a little bit higher than the lean-to. Now, the original timber beam that runs all the way down the garage from where the doors are to the back of the garage, that previously we were going to intersect with these I-beams coming through, and then provide support to the underside of these timbers just with some flat metal plate and some angle to beef it up. And then there was some angle iron running across with some basically some plates to bridge the gap and provide the support. Well, after your comments, I decided to revamp this and get rid of those beams altogether, and I think that was a great idea. A bit more work involved, but a much better job, and we're taking timber away from that whole structure. So all of this is now redundant. Instead, we can move across to this design, and here you can see again we've got these I-beams that cut across the workshop. There's one here and one here on the drawing, and we've got these new I-beams in place, and there are mounting brackets welded to the cross I-beams and then bolted to these longitudinal ones, and obviously there'll be 3 of these between the 4 cross I-beams across the workshop. So all of that timber's gone now out of the centre, and that leaves us with another problem now. How are we going to actually attach the I-beams, the longitudinal I-beams, to the roof timbers? And to do that, again, we're going to use metal plates, but I'll quickly show you what I mean. So here's one of the roof timbers that runs across. This is on the lean-to side. It runs across to the side there, look. And if we go up, this is the timber beam that runs all the way across from one end of the garage right down to the other. So the plan of attack is this is going to be replaced completely. These have to stay, and the issue we've got here now is connecting these to the I-beam. So there'll be a steel plate welded to the I-beam, it'll come across, and these are going to be cut down, and there'll be a steel plate bolted on to this timber, and there'll be another steel plate on the far side as well to sandwich that together, and then we'll have a nice steel to steel joint down here, look. It's perfect. Now that's pretty much the middle bit sorted out, and I'm a lot happier now with the new design. There's a lot more strength there. It's all steels, which means we're not reliant on any kind of sort of timber within that construction. And timber's always a bit iffy, isn't it? You know, it goes rotten, and it's hard to clamp properly because it gives a lot. So instead we're going to go with a full steel section in the middle. Now the only other difference is these 2 I-beams here that run from one side of the workshop to the other, and there's 4 of these in total running the length of the workshop from side to side. I've actually split them into two pieces because, again, there's a lot more. When you're putting a design together like this, you've got to be able to accomplish your goal, as in installation. Now, I can only fit beams up to 3 meters long in the trailer, so I can't buy a single beam that's 6 meters long anyway and transport it the 300 k's down to the workshop. It's just not going to happen, and to pay for transport is way too much. So these beams are going to be fabricated in two pieces, and there'll be a joining plate here, and these two joining plates will be welded to each side of the I-beam, and there'll be 8 M12 high tensile bolts around those I-beams holding those two pieces together. And of course they're going to be welded on to the I-beam, but my welding's pretty good, so I'm not concerned about the welding failing, and there'll be gussets and all sorts on there as well just to beef it up. Right, the ends of the I-beams, where it mounts to the sides of the workshop garage, these are going to retain that adjustable element where we can actually shim those. I've got a little close-up drawing that I did last time round. We can actually add shims between this interface here. It's a horizontal mount, and that was done deliberately, so I can put some shims in there and lift up the I-beam at one end or at the other end to bring that whole beam up nice and tight against the roof, so we know that we're supporting the roof fully and it's not going to droop down until tension's taken up by this new steelwork. Very important aspect to the design, that I thought. So there you go. It was just a really quick overview of the changes, and there's a lot more information in the first and second videos that I've done on this. It's quite a big project for me. I've done a lot of steelwork over the years, but not really steelwork for, you know, building construction, more for vehicular stuff, and it's quite different. One thing I did find was the biggest problem was was working out how much sag there was going to be on that beam, and is a UB14 beam suitable for, you know, spanning a 5.5 meter gap. Now each beam, I reckon, is going to be holding up about 250 kgs. That's not a lot. It's about, well, just over twice, yes, I know, just over twice my body weight. So it's not that much, to be perfectly honest. Of course, it's supporting its own weight as well. But there's 4 of these, and I've estimated the roof to weigh about 1 ton. It's only corrugated iron and a bit of timber, so it's not that heavy. But going online, looking at all the online calculators, which are really useful, but the answers that they gave me were completely meaningless to me. I couldn't work out how much droop we could expect to see. Now, you may have noticed in the design that half of the I-beam is an apex. So I've added an additional part to that based on your suggestions as the viewers, and I really do appreciate it, which should help to minimize the droop even more. Let's take a look. So one of the biggest problems is there are no triangles, and engineering is all about triangles. Triangles give us strength. So one of the suggestions was, why not, Andy, add an additional piece here. Sorry, I'm working around the camera now. Add an additional bar across here. Now, I know it's quite a shallow angle. It's probably not quite as shallow as this drawing makes out. And basically have a couple of mounts there and there. And that should help to beef up this whole half section of the I-beam that runs across, you know, the beam that's running across and supporting the roof. Because ultimately the force is downwards. And if we can beef up this section here, then it takes some of the flex out of the complete beam, and we should therefore see less sag. I can't do anything like that on this side because there's no apex there, it's just a flat beam. But by adding that, and I'll use a bit of, I think it's 50x50 angle iron, 5mm thick, to go between there, and again it'll be bolted into place via some mounts that are welded to the underside of these two I-beams. Also, another comment that came up is, you know, about these joints here. You know, we've got one I-beam here, we've got the other I-beam there, and of course it's welded together down here. And there was a lot of concerns about whether that weld was going to be able to cope with the stress of that roof. Well, just to be sure, I'll be adding some additional plates over that weld to spread the load, just to beef it up, and those plates will be put on both sides of the I-beam, and that should beef up that joint tremendously. I mean, you could even go the whole hog. You could even, you know, put a gusset underneath as well if you wanted, and maybe I'll do that. But I mean, basically, you know, how far do you go? Always work in progress. And don't forget, these are only fag packet drawings, which means I can always modify the design as I go. But going by those online calculators and the problems that I was having, I came up with a cunning plan. And that cunning plan was to do an experiment. You know, one way you can work out loadings and so on through calculations. The other way is to actually just test it. So we've got the I-beam, you know, and what I'll do first of all is we'll do a few tests. Seems we're going to do this because it should be interesting for all of us. And it'll be proof of concept, that's for sure. So initially I'll just get the two I-beams, the two halves. I'll weld on the two plates, which is going to end up at this point here. So we'll have the other I-beam here, look. We'll have a 5.5 meter span, and we'll support the ends of this with oil drums. Can you see all of that? You can, that's good. Okay, so we'll have an oil drum here, and an oil drum here. I think they're actually red and white, so you'll see that. And we'll make sure that this point here, the distance between the oil drums is 5,500 millimeters, which basically represents the two sides of the garage. And then off here, we're going to put a chain coming down, and we'll have a steel frame. And we're going to hang off there 350 kilograms. And we'll use the crane scale here, look. And that will record exactly how much load we apply to the beam. Now, okay, 350 kgs, that's more, it's about 100 kgs more than the actual loading the beam's going to have, because don't forget, the beam at this point in time is already supporting its own weight. And what we'll do is we'll take a measurement from the center of that beam down to the ground, unloaded, so there's no weight, and then we'll attach the weight to the beam, and we'll measure the difference, and that will give us the sag. And the sag is critical. And I think, personally, and I'm no, civil engineer, but I believe a sag of, say, 10 or maybe 15 millimeters is acceptable under that loading. If it's more than that, then I'm going to have to rethink the design. Now, once we've done that, and don't forget, there's no triangles there, it's just a straight beam, basically. That joint won't fail, I'm sure of that. And then what we'll do is we'll do the same test again, but I'll actually produce the first beam for the garage, that shape there, look, but without this cross piece. And we'll do the same test, and we'll see if the sag is reduced, and it should be. I think it should be anyway. And then we'll add this crossbar. We'll do one more final test, because that's the final design, and we'll see what the sag is with that cross piece, how much sag we can reduce by adding that one simple bar and creating a triangle in the design. Should be interesting, shouldn't it? So there you go, quick overview of Plan C for the steelwork for the roof of the workshop. Now, like I said at the start of the video, I have now ordered the steel. It's done, it's set in stone, and I'll be collecting that at the middle of next week and bringing it down to the house. Now, the workshop. Now, I've taken about a 10-day annual leave, so I've given myself 10 days of hard workshop labour to get all this steel work, well, to do the testing and then get the steel work, providing the testing works okay. I may have to revamp the design again, we don't know yet, and get all that steel work put into place, and finally get rid of this internal wall, this load-bearing retaining wall. It's got to go. Wish me luck. So, if you've got any more comments on this final design, please let me know. It's not too late for a few more tweaks. Like I said before, the steel is already on order. I can always get a few extra bits and pieces if need be. Something that I have left from the design, there's also going to be, I think, if I have time, some tensioning bars that run in a cross between each of those I-beams that run across the garage. I'll do your drawing. Here we go. Okay, we're getting really low on high quality cardboard now, sorry. So we've got, this is the garage, one side, that's the other side. It's actually a bit longer than that. There you go. We'll just lengthen it. Right, and we've got the 4 beams going across. This is like a bird's eye view of these beams crossing the garage. And we've got, running down the centre, in between each of these, separate I-beams that are bolted into place. and there will be little ones that stick out the ends that will have special supports on them as well. And on each side of the garage there will then also be some cross pieces just lurking up in the rafters. That's the plan. Maybe a bit overboard, I don't know. We'll do the same down this side. You know, maybe I only need to do the middle ones, but I'll decide later on. But that will, you know, bring the whole thing sort of under tension and provide a lot more support to the building. Probably find that it'd be earthquake proof after this, won't we? Should be good. So there you go. That's the last piece of the jigsaw puzzle. Comments down the bottom. You may think I'm completely mad. You know, I am really a mechanic. I do a lot of fabrication work, but not this kind of stuff. So please put your comments in. Let me know your thoughts on the matter. What would you do? But the design brief has a number of limiting factors. One is we need to maximize roof height. That's really, really important. I don't want this steelwork to encroach on the current space available. Two, you can't transport a beam any longer than about 3.3 meters. So bringing one I-beam along that would go full length of the garage, which is about 8 meters, is not going to happen. So it has to be built in sections and assembled and put into place in section. There's only me here to lift the beams into place. So again, having one beam that was full width of the garage, I couldn't lift that. I just couldn't do it. I haven't got, you know, all the acro props and bits and pieces to do it. So it does make it very, very difficult. But I think the plan that I've come up with, as cunning as it may be, might just work. Okay crew, well that's the end of this video. If you enjoyed the video, why not click on the subscribe button. You'll see a little gear icon turn up. Click on the gear icon and then you can tick the box and turn on notifications. You can just ring the bell, same thing, and our friends at YouTube will send you an email as and when I upload any new videos. And my apologies, it's been a couple of weeks since the last video went up. I've been away, been in the South Island, been up north, been to Sydney, I've been all over the place. I've been at home for one day in the last 2 weeks. Absolutely crazy. But things will very quickly change, and I'm very much looking forward to having 10 days non-stop in the workshop. I might even sleep in here. I enjoy it so much. Seriously. Bring the TV in, laptop, whatever, watch some videos on the evening. Just rock it out. I've got a lot of work to get done in those 10 days, and I need to get this finished. You know why? Because I want to get on and make some more videos for you guys. Okay, you'll also find me on Facebook, Instagram, and not Google+, because that's gone, and also Twitter. Feel free to communicate through any of those portals. If you want to email me, you can. The email address is andymechanic@live.co.uk. Also, thanks to all the patrons that now support the channel. It's your money that is helping to complete this project. And without you, it would be almost impossible. All right, crew, well, until next time, cheers. Over and out. And we get the flip up again. Oh. Yes.